Welcome back to the tutorial course on Android app development. In this lecture, we will discuss application development. As discussed in the previous lecture, our application will start with a splash screen and then will be redirected to a home page. On the splash screen, we can add an animation as per our application requirement. On the home screen, we will fetch the device location using the GPS and network providers and then show the location values. This location will then be used for fetching the weather data from the Open Weather Map service, which is a free online API service that provides the weather data according to the requested location details. On the next slide, let's look at the app development of a splash screen. On the splash screen, we will show the application name and a weather icon at the center as shown on the screen. We need to open the weather application in Android Studio. After opening Android Studio, we will first create a new activity called Splash Activity inside the weather app package. If required, we can revisit the Section 2, Lecture 2 to revise the creation of activities. To do this, we need to create a layout file for the splash screen called Activity Splash. Then, we have to create an image to show the splash image and set the splash image to the image view. After creating the image view, we need to create a text view below the image and align the text view to the center of the screen. Now both the text view and image view are created. While we are on the splash screen, we need to wait for a definite time before proceeding to the home screen. To show the wait time, we need to add a progress bar at the bottom of the text view and show the load time. We have now added all the components to the splash screen. We now need to check the splash screen in the design view. We need to add the wait time of 3 seconds to the splash screen. For this, we will add a handler object which will allow us to send and process the message and runnable objects associated with the thread's message queue. We then add the post-delayed method with the required wait time. The inside part of the post-delayed method will be executed after this specified time. We assign the time as 3 seconds, which is 3000 milliseconds. Inside the post-delayed method, we will create an intent with the name home intent to go to the home screen. If we recall, on the settings screen, there is an option to enable or disable auto location. If auto location is enabled, the application will show an alert message to the user. In our application, by default, auto location will be enabled. Now, we enable the default value and store the value in the shared preferences, which allow you to save and retrieve data in the form of a key and value pair. Then, we create a constant class to store all the constant values and shared preference keys that are used in our application. We will use shared preferences by calling the getSharedPreferences method, which will return a shared preference instance pointing to the file that contains the values of preferences. The first parameter is the key, and the second parameter is the mode. Apart from private, there are also other modes that are available. We create an instance of shared preference with mode as append mode, which will add the new preferences to the already existing preferences. We need to ensure that autolocation is, by default, enabled. To do this, we need to store the value as true. For storage, call the commit method of shared preferences. On the home screen, we will now fetch the current location using the GPS. To fetch the location, we first create a location fragment called addLocationFragment. Inside the fragment XML file, we will add a progress bar to show the progress. If needed, we can quickly revisit Section 2, Lecture 3 that talks about fragments and their properties. In the addLocationFragment class, we will get the location using two different methods. In the first method, we can get the location using the GPS sensor available in the Android device. In the second method, we can manually add the location. We will now add the addLocationFragment class inside the home screen. We now need to create a Location Manager object. Location Manager is an Android native class which is used for requesting location updates. We will access the Location Manager class using the Location System service. Then, we will create a location object to store the fetched location from the GPS. We will also create a string to store the city name. We then will add a progress bar to show the progress when the GPS location is being fetched. We will also check the status of autolocation if it's enabled. We have now stored the status of autolocation in the shared preferences. We will take the value from the shared preferences. If autolocation is enabled, the application should show the following alert message. Do you want to fetch the location using the GPS automatically? To display this message, we need to implement an alert function. We will now create an alert dialog box and set its title and message. If autolocation is enabled, the application should show the following alert message. Do you want to fetch the location using the GPS automatically? We will then implement the positive and negative button click events for this alert. When we click the Yes button, the application will go to the location settings screen where we can enable the location. When we click the No button, the alert message will be dismissed. When we come back to the application after location is enabled, the resume function will automatically be called inside the location fragment. Inside that resume function, we will request location updates using the GPS and network providers. To request location updates, we will use the request location updates method of the location manager class. In this method, we will pass the following arguments. Provider type, whether to use the GPS or a network. Minimum time required for a location update. We have defined 1 second, which is 1000 milliseconds. Minimum distance need to move for an update. We have set this as 10 meters. Current class object. We will discuss location listeners. To use location listeners, we need to follow the mandatory methods that will deliver location updates. If we change our location, an automatic call will be made to the location change method. We store the location in the location class variable. We now request the location using both the GPS and network providers. It is important to note that the GPS location is more accurate than the network provider location. To get the accurate location, we implement a function to get the best location from the last location available using both providers. Now, we will check the location availability time of both the providers. To get the latest location, we will check the difference in time and store the location with the latest time to the current location. By using the geocoder native class, we will get the city name from the location. We now will add a toast message function to show a toast message with the location details such as latitude, longitude, and city name. In the resume function, we will request location updates to receive the location details in the location listener methods. If we do not get the location updates, let's wait for some time and, thereafter, we need to show the last best location. We can implement the location updates using a handler, and after 10 seconds or so, we will know the last known location. We also show the progress bar that shows the loading progress. We first turn both the GPS and network providers off. Now, let's execute the application. As expected, first, the splash screen is launched. The auto location feature is, by default, enabled and, therefore, the following alert message is displayed. Do you want to fetch the location using the GPS automatically? We will click the Yes button. We have now enabled the location and are back into the application. As expected, the application now shows the location values. Using this location, we can now fetch the weather data using the free online API service. This brings us to the end of our discussion on application development.